Hi everyone, my name is Kang Min-gu and I'm here to present about our graduation work. The name is Using Photo Diode in Forklift Safety Line Beam. The contents of our presentation are organized like this. The first order is the research background. Have you ever heard or seen about the Forklift Safety Line Beam? Please look at the picture. Forklift Safety Line Beam is the straight light around the forklift. It has been used to prevent forklift accidents in various environments like an industrial site, a factory, and so on. The forklift safety line beam is normally mounted on rear or side of the forklift, and it used to red light source to give an impression of a warning. Next, I will talk about the forklift market trend. We want to know the size of the forklift line beam market, but there was no market stage for forklift line beam. So we tried to figure out the size of the market using an indirect method. Look at the graph on the left. As you can see, the forklift market is getting bigger and bigger. It increased by about 40% in 2020 compared to 2016. And look at the underlined part on the right. You will find out forklift safety regulation becoming stricter. So increasing the number of forklifts and stricter regulation based on two data, we thought the forklift safety line beam is marketable. On this page, I will talk about the necessity of our research. Line beams are already used to prevent forklift accidents in many industrial sites. But as you see the graph on the left, still more than half of forklift accidents between workers and forklifts accounted for over the past 5 years. And look at the underlined part of the article on the right. You can see that most forklift accidents occur while reversing. They use the safety device, but it's hard to check the rear, and then accident has occurred. So we thought we should add a back detection function to the existing line beam. The function is for the driver to recognize the worker's approach. This is our project goal. Next presenter, Yang Byung-moon, will explain the research objective in detail.
Hi everyone, now let me tell you about our research goal. As the previous presenter said, the function of existing line beam and the function of the driver to recognize workers approaching the line beam. The goal of our research is to develop a new line beam that has both functions. Please look at the picture on the screen. Our goal is to develop an object recognizable line beam, but it's divided into three parts: light emitting part, light receiving part, and Arduino. The first goal is to design a light emitting part with a line shape and a high luminous value, as shown in the picture. The second goal is to enable the photodiode to detect the reflected light in a certain area. The final goal is to make the driver can recognize the object in the line beam by using Arduino. In conclusion, our research goal is to develop a line beam that can recognize objects using a photodiode. On this page, we have shown the target specifications of our research goal as a table. Please look at the table. As you can see, we have set the target specifications using optical software, GMAX, and light tools. First, we have set the overall goals of the optical system by using GMAX. And then we have set the overall performance goals of the optical system by using light tools. In the light emitting part design, considering the distance between the line beam and the forklift, we aim to have an irradiation distance more than 1,500 millimeters. And also we made it visible in many environments, so we aimed its illuminance more than 1000 lux. In the light receiving part design, we considered the photodiode size, so we aimed to have image height less than 3.74 millimeters. Also, we considered the size of receiving area, so we aimed photodiode's FOV less than 8 degrees. Finally, to create a line beam that enables object recognition, we aim to make a difference between the intensity of entering light at PD when there is an object or not more than 5 times. From the next page, the next presenter, Park Hee-sung, will explain the research methods in detail. Thank you.
Hello, now I'm going to talk about research methods. The research method was designed in 2 ways. One is GMAX and the other is light tools. First, we designed the light emitting part using GMAX to satisfy line beam width of 200 mm or less when irradiation distance is greater than 1500 mm. We use a cylindrical lens and 2 spherical lenses as shown in the layout on the left. Also, as shown in the right lens data, for the production of cylindrical lens, the material is designed by acrylic. In addition, we complemented light tools considering the wavelengths and emission angle of crisis LEDs to be used during the production process. The middle figure shows the LEDs and lenses implemented by light tools. In order to satisfy the average illumination of line beam 1000 lux and line beam size 1000 mm x 200 mm, we arrayed the LED as shown in the picture on the right. GMAX and light tools were able to design the light emitting part of the line beam. Next, I will talk about the design of the light receiving unit using GMAX. The picture you see on the left is the photodiode of Osram company that we are going to use. The photodiode receives a light area of 2.65 mm x 2.65 mm and a diagonal size is 3.74 mm. So we use spherical lens as shown on the right to receive reflect light from the line beam at a certain angle. Next, Mingyu will explain simulation part. Thank you.
Hello, now I'll continue to present the research methods for light receiving part. Look at the left figure. The figure on the left shows the tilt and array of the light receiving optical system. It is a line beam, a lens, and a photodiode. Divide the line beam into 5 circular regions of equal size. Use a tilt and array to make the light receiving range equal. Through this, reflected light from all regions can be received. The table on the right shows 4 types of fluorine materials commonly used in forklift work environments, and it shows reflectance according to the material. When implementing a simulation environment, the reflectance of 4 types of materials and Lamberian scattering were applied in irradiation surface. Look at the figure on the left. The figure on the left shows no object in the line beam area, and the right shows object exists in the line beam area. Light from the line beam optical system is irradiated to the surface, and this square is a line beam. In the figure on the right, the object is placed in the area 3, and the line beam corresponding to area 3 is not visible. Through the implementation of an illuminance simulation environment measures the difference in light intensity of PD according to the presence or absence of an object. Now, let me tell you about our research result. The left picture shows the results of the line beam illumination simulation. And these two pictures are light intensity graphs that come into PD when objects are absent or exist in area 3. As a result of the illumination simulation, the average illuminance is 1260 lux. It was confirmed that the target value was satisfied. Comparing two graphs, light intensity when an object was present was 8 times higher than when an object was not present. These results confirm that object recognition is possible. From the next page, the next presenter, John Yoo-ho, will talk about comparing the result specification with the target specification in detail. Thank you.
Hello, I will compare the target and result specifications from now on. This table shows the evaluation list, target specifications and result specifications of the light emitting and light receiving part and light tools illuminance simulation. The irradiation distance of the light emitting part is 2000 mm higher than 1500 mm. The image height of the light receiving part is 3.24 mm smaller than 3.74 mm, and the FOV of the photodiode is 7.8 degrees smaller than 8 degrees. The result of the illuminance simulation using light tools was 1260 lux higher than 1000 lux. In addition, the gap in light intensity of photodiode, according to the presence or absence of an object, was 8 times bigger than the 5 times. All of the specifications met the target specifications, but the size of the line beam was 1200 cross 250 mm. It didn't satisfy the target specification of size 1000 cross 200 mm. So we are going to improve this part until the next presentation. Next is our research plan. We will solve the heat generation problem of the high power LED. So the exterior of the line beam will be modeled by applying the heat sink structure. Also, we will use an illuminance meter to compare the line beam illuminance simulation result with the actual measurement. It's our research schedule. We have completed the thesis and patent investigation. Currently, the optical system design of the light emitting part and the light receiving part is in progress. In the future, it is planning to simulate light tools illuminance, manufacture prototypes, evaluate performance, and improve problem. The last is division of roles. We will do our best to show our good result. This is the end of the Forklift Safety Line Beam team presentation. Thank you for listening our presentation.